Welcome to episode 47 of the Pulse of Physiology. I'm your host, Dr. Jim Davis, and today we're going to discuss blood typing, a critical concept in transfusion medicine and immunology. Blood type determines compatibility for transfusions and organ transplants, as well as how the immune system reacts to foreign red blood cells. By the end of this episode, you should be able to explain how ABO and Rh blood groups are determined, why antibodies play a key role in transfusions, and what happens when incompatible blood types mix. So let's dive in. Blood type is determined by the presence or absence of antigens on the surface of red blood cells and antibodies in the plasma. Antigens are proteins or carbohydrate markers that are attached to red blood cell membranes. The two primary antigens that determine ABO blood type are A and B antigens. Antibodies are proteins found in plasma that bind to and attack foreign antigens. If a person is exposed to a blood type with antigens they do not have, their immune system will produce antibodies that cause agglutination, which is clumping of red blood cells, which can lead to dangerous complications. The ABO system is based on the presence or absence of A and B antigens on red blood cells. The name that you're given, or the name of your blood type, really depends on your antigens. Type A has A antigens on the red blood cells, but anti-B antibodies in their plasma. Type B has B antigens on the red blood cells and anti-A antibodies in their plasma. Type AB has both A and B antigens on their red blood cells, but does not have either of the antibodies in their plasma. Finally, type O has no A or B antigens on the red blood cells, but it does have both anti-A and anti-B antibodies in the plasma. Now, if a person receives an incompatible blood type, their immune system will recognize the donor red blood cells as foreign, and consequently an immune response will be triggered. Antibodies will bind to the foreign antigen, leading to agglutination. Remember, that means clumping of red blood cells. The clumped red blood cells can block blood vessels and reduce oxygen delivery. The immune system destroys the clumped red blood cells, which can release toxic byproducts, potentially leading to kidney failure or shock. For this reason, proper blood typing and cross-matching are essential before transfusion. Now, in addition to the ABO system, blood is classified as Rh positive or Rh negative based on the presence or absence of the Rh or D antigen. So someone that is Rh positive has the D antigen on the red blood cells, but no anti-D antibodies. Conversely, Rh negative has no D antigen, but they do not naturally produce anti-D antibodies. That is, until they are exposed to Rh positive blood. So if you have a negative blood type, you definitely don't have the D antigen, but you might not have the anti-D antibody. The only reason that you would have the anti-D antibody would be if you were exposed to that positive blood. Now, the Rh factor is especially important in pregnancy. If an Rh negative mother carries an Rh positive baby, she may develop anti-D antibodies during delivery when fetal blood mixes with maternal blood. Now, during the first pregnancy, this is not an issue because the mother has not yet been sensitized and she has not created those antibodies. However, in a second pregnancy, the mother's anti-D antibodies can cross the placenta and attack fetal red blood cells, which causes hemolytic disease of the newborn. To prevent this, Rh negative mothers receive Rh immunoglobulin RhoGAM to prevent sensitization. So during transfusions, only red blood cells are typically given, meaning we are concerned with antigens on the donor's red blood cells and antibodies in the recipient's plasma. So we have the universal donor, which is O negative. O negative red blood cells have no A, B, or D antigens, meaning no antibodies in the recipient plasma can attack them. And so as a result, O negative is the universal donor for red blood cell transfusions. The universal recipient, on the other hand, is AB positive. Now, AB positive individuals have A, B, and D antigens, but there's no antibodies in their plasma, meaning they can receive red blood cells from any blood type because they don't have any antibodies to attack those red blood cells. To summarize, we've got 5 key takeaways. ABO blood types are determined by A and B antigens on red blood cells and corresponding antibodies in plasma. Incompatible transfusions lead to agglutination, which can be life-threatening. Rh factor determines whether a blood type is positive or negative. Rh negative individuals can develop anti-D antibodies after exposure to Rh positive blood, which is important during pregnancy. O negative is the universal donor for red blood cells, while AB positive is the universal recipient. So that's it for episode 47 of Pulse of Physiology. I hope this episode has clarified how blood typing works and why it's critical for safe transfusions. Join me next time for episode 48, where we'll change systems and explore the respiratory system and its functions. Until then, keep questioning, keep exploring, and stay curious.